This is section 821. We're going to take a look at reciprocal trig ratios. So by the end of this lesson, we're going to be able to state all 6 trigonometric ratios and evaluate ratios of the sides of a right triangle using those 6 basic trig ratios. So remember, from a given angle, we can say that we have a side that's opposite, a side that's adjacent, and then always opposite the 90 degrees is going to be the hypotenuse. This framework is going to be the same when we establish the original 3 trig ratios. And so for those original 3, we said that we had a sine ratio, a cosine ratio, and a tangent ratio. So now we're introducing the reciprocal ratios. Now what happens, because it's like I said opposite to the hypotenuse, but what if I flipped it? What if I said hypotenuse to the opposite now? Well, we call that the cosecant ratio. Instead of adjacent to the hypotenuse, what if I said hypotenuse to the adjacent? That's going to be the secant ratio. And instead of opposite to the adjacent, I say adjacent to the opposite. That's going to be my cotangent ratio. So these 3, cosecant, secant, and cotangent, those are going to be my 3 new ratios. Now, the abbreviations, it's not ksk, it's cosecant. It's not sec, it's secant. And then cot, nope, cotangent. So we need to say cosecant, secant, cotangent. Again, you need to have them memorized. Now, the nice thing about it is we call these reciprocal ratios. Because once you know sine, cosine, and tangent, all you need to know is which one relates to the other. And to help us memorize that, it's helpful to think maybe S goes to C and C goes with S. So S goes to C, C goes with S. So S goes to C, C goes to S. Now, and then tangent and cotangent, easy to remember that those are associated with each other. But when we do this, if you notice the writing here, it's 1 over. We call that reciprocal. These are reciprocal identities. So if I find my sine ratio, and then I want to turn it into cosecant, I just flip it. If I find my cosine ratio and I wanted to turn it into secant, I just flip it. Likewise, if I have secant and I want to turn it into cosine, I just flip it. Same with tangent and cotangent. So S goes with C, C goes with S. That's what kind of helps you remember which one's associated with each other. And to convert, it's the reciprocal. So let's look at some examples. I want to find cosecant of theta and secant of theta. So to do that, we're still going to start with our SOHCAHTOA. We still need to know that. So sine of theta equals opposite over hypotenuse. The cosine of theta equals adjacent over hypotenuse. So now we just convert them into the reciprocal. S goes with C, S goes with C. So that means that cosecant is the reciprocal of sine. All you have to do is just flip the ratio. That's the reciprocal. And then cosine and secant, you just flip to find the reciprocal. So one more example here. If I wanted to find the cotangent of 30 degrees, so the cotangent of 30 degrees, well, I know cotangent is aligned with tangent. So tangent of 30 degrees is opposite over adjacent, so SOHCAHTOA. So that's 8 over 8 radical 3. So the cotangent, you just flip it, because it's the reciprocal. So 8 radical 3 over 8, the 8's cancel out, and you're just left with radical 3. So what did we learn today? We talked about the reciprocal trig functions, and the way that we find them is you originally find the sine, the cosine, and the tangent, and then you just flip to convert it to the reciprocal. And we know that sine goes with cosecant. We know that cosine goes with secant, and tangent goes with cotangent. This does conclude our lesson. If you have any other questions, please leave them in the